Okay, so I'm glad that you told what's DApp and what's Ethereum. So right now I will show you something. So there's only one technical person, some people that are familiar. How many are technical? Oh, okay. So we have more. We have 50% technical people, 20% like in Web3, and maybe the rest are shitcoin traders. And I guess yeah. But this is also helpful for you. So today we're gonna talk about how to scale our DApps or how to use a scalable DApps using Neon EVM and how we managed to do it. So I've read a tweet 1 week ago or 2 weeks ago that currently the state of Ethereum is like that. You want to order an Uber here in Barcelona, and instead of $10 paying for Uber, you pay $100 because there's a concert in Madrid. And this is actually the state of Ethereum because how gas prices are estimated in Ethereum, they're global. So it doesn't matter if there's like a NFT, some degenerates buy NFT or buy Pepe, like the gas price for the whole network will become higher, and you will not be able to send your tokens anywhere without paying like $50. And for the regular user, this is a lot. Like, let's say you are dealing with your, if you want to use blockchains for everyday life, we should not pay like more than 0.01 cent for transaction, or even less if we're using microtransactions. So how we are achieving this is basically we are combining the best of both worlds. So we are using Solana. Why Solana? Because Solana is one of the most capable blockchains to scale. So you asked, that's another blockchain that you asked, but again, it's not a financial advice. That's a good blockchain. So why is good? So Solana is really different beast from Ethereum. It has a very different architecture, and its architecture is just to scale. And I will explain you why in a second. So we built EVM, an Ethereum virtual machine, which lives inside Solana. It's like having a Mac OS virtual machine inside Windows or vice versa. And why we built that? Yes, Solana is good. Solana is very great, but community, why this doesn't disappear? But sorry, I wanna maybe, yeah, like this is better. But so Solana is very good, but we believe that community and tools, even like users around Ethereum are really more vibrant, and it's really more developed than any other community. So we think that in the future, EVM community and Ethereum community will thrive even more. But as we mentioned, why all those blockchains appeared after Ethereum? Because of high gas prices. Like, people are not being able to use it. Only big companies with millions and millions, they can do 1 or 2 transactions, because otherwise, if you go for 20% or 10% yield in some protocol to earn 10%, if you pay 10% for this transaction of your money, because let's say you want to transact with $300, you pay $30, it means that you need to stake for at least 1 year to be break-even. So we are having the best from Ethereum, like no code changes for your smart contracts if you're a builder, or if you are just a user, you don't need to have multiple wallets. For example, Solana uses Phantom Wallet, and all other EVMs, they use MetaMask and others. So with one wallet, with let's say you're using Ethereum, with MetaMask you can use Neon EVM. And these are our metrics. So currently we reach around 1,000, but on paper, and in theory we can reach 2,000, and it's just a matter of configuration. This month we're gonna be going for 1.5 thousand transactions per second, because it's really a matter of, I would say, fine-tuning of our infrastructure. The gas fees are around 0.001. They were really lower, but because Solana price went up, and don't buy now, buy after 1 month maybe, I don't know, but just don't buy when it's green, buy when it's red, yeah, when everyone is scared. So that's why the gas prices went down. So this is our main infrastructure, because we have our EVM. Our EVM is actually our execution layer. Basically, this EVM, it understands Ethereum bytecode and can execute it inside Solana virtual machine. So it's like a smart contract, a different program inside. We also have proxy, which is our Ethereum, as you mentioned, RPC. We have like an interface, the same as Ethereum, because wallets and other tools, they interact with this interface. So if you want to be fully compatible with Ethereum tools, we need to have a fully compatible interface. Tracer API is a little bit technical. We have an interface for tracing transactions. So when you go to a block explorer and you see one transaction that you transferred these tokens, or you deploy the contract and you code a couple of other protocols, those blockchain explorers under the hood, they're using Ethereum tracing method. So we have also fully compatible tracing API. Neon Pass is just a faucet for DevNet. We have a DevNet where you can just go get some DevNet neons and play around with our DevNet. Actually, this is Neon Faucet, not Neon Pass. Neon Pass is our bridge from Solana to Neon EVM, which is a native bridge. So there's no actually bridging or message passing. I'll show you how. And Neon DAO, which is basically the owner of Neon EVM. Any change to Neon EVM should be voted in the Neon DAO. This is some of our ecosystem, and as you can see, wallets, MetaMask, Wallet Connect, Ledger, Math Wallet. For multi-signatures, we have Safe, bridges, Neon Pass and the bridge. Currently, we are not integrated with the bridge, but we announced our partnership. And we have Block Explorer. So basically, if you are a dev, EVM dev, you're for sure familiar with those frameworks. And also, because we are inside Solana, we support those Solana programs to be called natively from Neon EVM. And now, this is also another representation of our tooling, especially. And we support Foundry as well, which is very trending among smart contract security researchers and developers and so on. So let's just see in a nutshell what Neon EVM is. So this is Neon EVM, as I mentioned. It's a program like a smart contract inside Solana, and it understands of EVM bytecode. Bytecode is the actual machine language that the virtual machine understands of this language to perform some operations, and it can translate this bytecode and execute it inside Solana. And it's not that easy. It's very hard because Solana has different architecture and has very different limitations. But with having only our smart contract in Solana, we will not be able to be fully compatible with Ethereum. Like, you will not be able to use MetaMask, you will not be able to deploy your smart contracts with your EVM tools. So we built our Neon proxy, which from one side, it accepts Ethereum transaction, and it composes from this Ethereum transaction a Solana transaction, and sends it to our EVM to be executed. So this looks scary, but I'll try to explain it in a little bit different fashion. So this is how a Solana classical program looks like. And it's very, very different from Ethereum. So Ethereum is a state machine. So Ethereum, we have one program. This is the program. And we have one state. So in order to save this state, after miners conclude one block is actually, let's say, 100 transactions in some order. This block changes the whole state of Ethereum. So it's like one virtual machine with a big state. Solana is very, very different. Imagine Solana being like a file system. So we have a file system with two types of files. We have executable files and we have data files. So in Solana, programs in Solana, they're stateless. They don't have state. So let's say we want to create a program that will record balances of users. I send you one token, now you have one, I have 10. I send you one, now you have one, I have 10, and so on. So the state of our program is actually the balances, right? The ledger. Here in Solana, the program creates itself to store the state. It itself creates data accounts that are actually files, like text files. You can imagine like text files that can store the data. And it stores the data inside this variable, data. So here inside the data, if this is the executable, the bytecode of the program, but the program itself stores in different files its state. And I'm not going to go in details, but with this architecture, if you submit two transactions that are going to modify different files, they can be executed simultaneously in Solana. And this is parallelization. In Ethereum, you can't have that. Ethereum, you should process transaction one by another in the same order they appear in the block. So if you have in a block 100 transactions, they will be executed in the same order. That's why there is math bots that, and if someone can front run you, that's when someone can front run you. They just pay more fee, and the miner, of course, he will choose to get their transaction over yours, and he will put your transaction on top of the other person. So Solana is stateless, and this is how actually Neon EVM works. So Neon EVM, as I mentioned, it's a program. And we abstract, with Neon EVM, we abstract away all the complexity of Solana. And for Ethereum, the same as with Moonbeam and Polkadot. Polkadot have different addresses. Also, Solana have different addresses than Ethereum. So this is what represents one user account. You can see inside the data, we have all the Ethereum state of this account. We have the Ethereum address, the nonce, which is number of accounts, number of transactions this account have created, the balance, and so on. So this is also a smart contract. It has like the EVM bytecode, and the smart contract stores its state through the contract data. And basically, this is how we abstract away all the complexity of Neon, and the user should not care about that. This is something that maybe I'll skip, but I'll show you how Solana transaction works and what is the difference. So the biggest difference between a Solana transaction and an Ethereum transaction is the account list. This is the most important. We have also program index and data. So the program index will always be the program we are calling with this transaction. So here it will be the program index of Neon EVM in this account list. Let's say we have 10 accounts that we are going to call in this Solana transaction. If Neon EVM is the first account, here the program index will be 0. And why the account list is important? It's important because, as I mentioned, we have 2 transactions in Solana cluster that enter. If the account list of those 2 transactions contains different accounts, those transactions will be executed simultaneously. So with one, we can have actually what feature we can have is basically the gas prices are only local for the DApps. Let's say you create NFT collection and you create, let's say, some shitcoin that it goes very trendy. So the gas prices only for your DApp will go up, but the gas prices for your NFT collection, if someone wants to buy it, will not go up because both the transactions will be executed simultaneously. They will have different account lists here. And yeah, this is the actual that's the actual picture that represents parallel execution. And what are the most important incoming features? So what we currently have is we have only the Neon Pass, which is our native bridge. So with this bridge, you can only bridge from Solana to Neon EVM because we are inside Solana, so we just do simple transfers. Those live in the same blockchain. So this is pretty easy and straightforward. The integration with the bridge will actually allow Neon EVM to connect with 16 more blockchains and people to be able to bridge their assets into Neon EVM. And not only assets, maybe some, it's a cross-messaging protocol, so you can pass any message. So you can build any application on top of it. Many protocols have deployed on many chains and they have cross-chain governance. So maybe they can deploy Neon EVM and use their message passing to vote on different kind of changes or something like that. And something that we announced is live on DevNet currently is alternative token gas payment. So currently you can pay, and this only on DevNet. On mainnet it will go maybe around Q1 because we need to do security audits and yeah, we have a process in place. So basically currently you'll be able to pay with any token that you have. Currently we'll start supporting 4 or 5 tokens, USDT, USDC, Solana and Neon. And you'll be able to pay with any of them when creating a transaction. And this will be very easy. You just need to change your network. Basically, we're gonna have in your wallet, you're gonna have, let's say, Neon pay with Solana, Neon pay with Neon, Neon pay with USDT, and so on. And basically, it's really, I'm not sure, maybe it works. You see, I deployed some contract on Ethereum. It's 5 hours, and still the transaction is not pending. It's still pending, but this is because I didn't want to pay $100, but I wanted to pay $30. So now I'm waiting until the gas prices are. Yeah, yeah. And so if we see now, for example, this is MetaMask. And okay, you can see we have Neon, but let's see if testnet is working because it should show some. No, it's not working. That's very bad. But basically, you will have to testnet is not working because we're using devnet. So devnet is working. We have Solana have testnet, devnet, and mainnet. So devnet is the thing we are using actually, but testnet it was only deployed for last week. Right now it's migrated to devnet, but I'm not sure which are the RPCs. So yeah, basically you have like, let's see, Neon SOL, so you'll be able to pay with SOL, or let's say Neon to pay with Neon. So, sorry? Yeah, to pay the gas with any currency. So you have just different networks, but actually it will be the same network. You know, this is just abstraction from wallet perspective. Yeah, and our last goal, maybe for next year, is to achieve general composability with Solana. It means that from your DApp to be able to call any other DApp in Solana, and this is quite technical, quite a technical challenge, and it's really hard to explain. But the same way we are currently right now reading price feeds, chaining price feeds from Solana. We don't have chaining price feeds on Neon. Also, you can deploy ERC20 token in our chain that is basically a Solana SPL token under the hood. So yeah, it's really hard to understand. I'll not talk about that more because it's really hard to understand. So yeah, that's pretty much it. We are quite new. So we launched in July, and yeah, currently we're just building, and yeah, I think that's pretty much it.
You are not in relation with decentralized Postgres, Neon.
No.
My question was, you are not in relation with decentralized Postgres, Neon Tech.
No, we're not in relation with
good.
Neon Tech. I've heard it just now.
Okay, so I have one question. I mean, are there any other EVM-compatible like technology like yours already on Solana? And in that case, how is it different from that other? In the case that it exists, how is that different? How is yours different? Because what I saw is that it looks super cool.
Yeah.
But I don't know if there's any other way to pack the Ethereum transactions into this Solana transaction. Because
you mean if there are any other projects that do similar things in Solana?
Exactly.
No, we are the first. We are actually the first. So basically, the story behind Neon, it comes from I'm not sure if it's an open source project. It was called Sputnik. It was EVM on Solana, but they didn't develop it. So we started from this foundation, but currently it's way further. We went way further because we are really well funded. We have 30 people in our dev team. So it's like a very big organization right now, and I would say that yeah, it took around 1 year and a half or 2 years to build. So it's really hard because if you interact with Neon and go into our browser.
Yeah, it's very, and that's why I was actually. Because I know that it's very hard.
I don't have internet. That's why.
That's why the transaction is pending.
Yeah. Oh, it's still pending. Don't worry about that. And yeah, I mean, it's been really challenging because Solana has a lot of limitations. So sometimes one Ethereum, like EVM transaction, consists of 30 or 40 Solana transactions because they are very small, and they're completely too different. It's like having a race car and like a bus. You know, I don't know. I just can't measure them both. They're completely different architecture.
So what do you mean is like Solana transactions I mean, you can feed less data, and the Ethereum transaction has a lot of data, so you can use parallelize.
Yeah,
that
yeah.
Ethereum
So yeah,
transaction.
so you have a lot of memory restrictions in Solana transactions, where in Ethereum you have 3 million gas. That's the restriction. That nothing else. So if you have a transaction up to 3 million gas, if it's 3 million gas, your transaction, one miner will mine this transaction, and you have one block with one transaction. That's it. And but in Solana it's pretty different. Yeah.
Okay, great, thank you.
Thank you.
Any other question? No? Here. Wait. To you. Here? Here?
Hello. Can you explain a little bit more about the differences when you transact with different tokens, about the gas price? You mentioned that would be different, maybe, as far as I understood.
The gas price will be different if you interact with different smart contracts. I mean, this is how Solana works. So basically, in Ethereum, everything is sequential. Let's say you have those transactions, they're gonna get processed one by one, and the gas price is global for Ethereum, right? If the network is very, very congested, the gas prices will go up. Here in Solana, the gas prices are local gas prices. What does that mean? They are per application. Because if those transactions use one application, they will, let's say this transaction uses application 1, this transaction uses application 2, this transaction uses application 3. They use completely different applications. It means that they will get processed by Solana in parallel, and the gas price will not go up for the whole network. The gas price can only go up for one particular DApp. I mean, if the network is really, really congested, maybe the gas prices will go a little bit up for the whole network, but they will not. They go up based on usage of just a specific DApp.
Okay, but that would be related to the token itself, or by the contract that is interoperating with?
The gas price?
Yes.
The gas price, basically, the gas price is how much you pay for your transaction to be executed.
I know, but what I mean, what would be the difference between interacting with a specific token and with one of those slots that you mentioned there? Like one of these, I don't know how you
mean
call it
interacting with any basically, if you look, so the only accounts that we are going to interact is the data accounts. So in the account list, we have data accounts, because the data accounts are the only accounts that store state, right? So we don't want to have two same transactions that are going to modify this account to be executed simultaneously, right? Because we're going to have racing conditions. Like if maybe this transaction will read a false state. So basically, if two transactions will modify the same account, basically they will be executed one after the other. And if we have 1 million transactions like that, the gas price to change this account will go up. But if we have one transaction to change this account, it will just be processed simultaneously, and the gas price will not be as big as the one for this.
Right. So I understand that it's more related with the person or with the wallet interacting with a contract than with the price of the token itself or with the.
Yeah, it's more so the gas price actually doesn't have to do anything with the price of the token, because the gas price is basically multiplied. The gas price tells you how many Solana you will pay, not how many dollars you will pay.
Now.
So
Yes, yes.
if you pay 0.1 Solana, you will pay, let's say, $5. But if the gas price go up, you will pay then $6. You know, we don't care about, yeah.
Yeah, thanks.
Yeah, you're welcome. Yeah. Yeah?
Yes, about this. Okay, the Neon.
With the mic.
Yeah. So the Neon EVM is a program deployed on the Solana blockchain,
Yes.
right? So what is the Neon contract? Is a Solana contract?
No, Neon contract is any contract you want to deploy.
Okay, right.
Let's
So
say-
it may be even an Ethereum Solidity Ethereum contract.
Solidity contract, like
Okay.
Aave or Uniswap
Okay,
or
I see, I
any
see.
contract, yeah. This is, everything happens from here. This is our execution layer. You want to deploy a new contract, you submit a transaction, you basically submit a transaction to the proxy, right? The proxy creates the proxy unwraps the Ethereum transaction and creates this Solana transaction with program index Neon EVM smart contract, and submits the Solana transaction to a Solana node calling Neon EVM. And if this Ethereum transaction was deployed, let's say, if it was like deploy smart contract with this bytecode and so on, the Ethereum, the Neon EVM will just create a new Solana account that will contain the bytecode here. It will create it will compute the Ethereum
So
address.
for each transaction, a new Neon account is created.
No, not
okay.
for new.
Okay.
But
For
because
each Ethereum transaction.
let's say you want to deploy a new contract. How do
Yeah.
you deploy a contract? You create a new Solana account storing the contract bytecode.
Okay.
Balance is 0. Maybe you compute the Ethereum address. You know how you compute with create or create to opcode. All the opcodes are here.
Yeah.
So it creates the account here. It's way more complicated, you know. It's but in a nutshell, it's like this. This is like
So, yeah, but
It's like a Solana contract with like EVM bytecode in the
Yeah.
storage, basically.
yeah. A Solana contract with EVM bytecode in the storage. This is like a storage file. And when you want to execute, like Neon EVM understands this bytecode. It can execute this bytecode inside.
okay, perfect. And so, and when it's the Neon contract data, instead, it's also like
This is the
storing.
state. This is the storage of the Neon contract.
Yeah. Okay. So it's not gonna be also representing the storage of the Ethereum, let's say, contract itself. So the Ethereum.
It represents the
Ah.
Ethereum contract itself. Yeah.
Okay.
Let's say you have a variable there.
Yeah,
and-
exactly, it's gonna be
and
there.
you store the variable here, yeah.
So basically, because of course Solidity and Ethereum doesn't have this storage representation, so I guess the Neon EVM engine or whatever is gonna do this process of.
Yes, of course.
Okay,
of course.
so all
It's a-
this process of dividing, making this new storage representation is done by the Neon EVM.
Yes, of
Okay.
course. But it follows, of course, EVM rules,
Yeah,
right?
of course, okay.
It follows all EVM
Okay.
rules, but under the hood, for example, it creates one account, 2 accounts, you know. It understands how to navigate into Solana virtual machine, because Solana virtual machine is different.
And there is any overhead in the execution speed of, let's say, in the interpretation of the smart contract execution?
You mean? Sorry?
Is there any overhead introduced in the execution of the smart contract? Because of course, I guess you have to,
in
take
the
care of all these.
in the execution, there's no overhead because Solana is really fast. I would say there is overhead in this part, composing the transaction and then submitting transaction to Solana node. Because sometimes, as I mentioned, one Ethereum transaction is 40 transactions on
Yeah.
Solana. So we need to wait for.
Okay.
We have around 10,000 connections to Solana, and sometimes maybe something can get, but we get around 0.4 seconds is one block. So, but yeah, but the problem is more of an infrastructure problem rather than execution inside Solana.
Okay, perfect. Thank you very much.
Thank you.
Right. Thank you guys.
Yeah. Thank you.